So for this question, we're given the function f of x is negative log base 2 of x minus 4. Let's think about the domain and the range. So first, let's look at the domain of f. And what can I say about that? The argument of a logarithmic function cannot be a negative number, cannot be 0. So the x minus 4, the part that comes after the log base 2, must be strictly greater than 0. So that tells me x is greater than 4. So in terms of my domain of f, here's 4. I remove that because, again, I cannot take the log of 0. And then I shade everything to the right. So in interval notation, the domain of f would be round bracket 4 to plus infinity. Let's take a look at Desmos and see if that gives us the same answer. So f of x equals negative log to get the base, shift underline, log base 2 of x minus 4. And let's look at the domain. What are the x values I see? Well, x could be 5, it could be 6, it could be 7, it could be 4.5, could be 4.1. Notice it's getting very, very close to 4, but never actually getting to 4. What did we say the domain was? We said the domain was 4 to infinity, so that looks pretty good. Now what about the range of f? Let's take a look at the graph again. Range of f. Well, you can see that the y values get as high as you want them to get, right? You want a y value of 16, boom, there is one. Now, how low do they get, though? That's a little harder to see. So to get a better feeling for how low it could go, like, does it ever actually get to negative 25 in the y? You might think, negative 250, well, that's even crazier. But it does get there. It's just to get to negative 250, I have to have a very, very large number. So just to make that point a little easier to see, I'm going to try to convince you that this graph eventually gets to negative 25 or below. And to do that, I just need a whole lot more x. So right now, x goes to 32.29. There's x 100. Now it's 1,000. 10,000, 100,000, a million, 10 million, 100 million, a billion. Now you see it eventually gets lower than negative 25. So the y value does go as far as you want it to go. The x value, the y value goes up as far as you want it to go. So the range of this function is indeed all real numbers. So the range of f is minus infinity to plus infinity. Now let's put that aside. We're going to do some analysis with this later. But I want a graph. I want to graph f next. Let's do that with some point plotting. We have the graph currently on Desmos. So I have f of x is negative log base 2 of x minus 4. And let's assume that we didn't have a grapher. We wanted to graph it by hand. How are we going to identify points to do that? Y is negative log base 2 of x minus 4. Let's multiply both sides by negative 1. So negative y is log base 2 of x minus 4. I like to write the log on the left. So I'm going to say log base 2 of x minus 4 equals negative y. The base is 2. The exponent is negative y. 2 to the negative y will equal x minus 4. So rewriting from log form to exponential form, 2 to the negative y equals x minus 4. Let's add 4 to both sides. So 4 plus 2 to the negative y equals x. And that is what I'm going to use to create my table. So my y values are what I'm going to plug in. So this is unusual, and I'm plugging in y to see what x is going to be. If y is 0, what is x? Well, what do we know? X is 4 plus 2 to the negative y. So if y is 0, we're going to get 4 plus 2 to the negative 0. That's 2 to the 0. So 4 plus 2 to the 0 is 4 plus 1, which is 5. So the first point on my graph is 5, 0. So let's go back to Desmos. And let's see if the point 5, 0 is indeed on the graph. And it is. Very good. Next up, let's plug in a y of 1. So I get x is 4 plus 2 to the negative y, 2 to the negative 1. That's 4 plus 1/2. That's 4 1/2. So let's see if 4.5, 1 is on that graph. Four 4.5, 1. And there you go. That looks good. And next I want y to equal 2. So before I do that, let's think about what we think it's going to be. If y is 2, the number is something between 4 and 4.5. Notice it's less than 4.5. So if y is 2, what is the x value I'm going to get? Y is 2. X is 4 plus 2 to the negative 2, which is 4 plus 2 to the negative 2 is 1 over 2 squared. 1 over 2 squared is a quarter. 4 plus a quarter is 4.25. Did that satisfy our guess, our prediction? Let's take a look. 4.25, 2. And you can see, there it is. And then as we get closer and closer to 4, the numbers get larger and larger, right? Or if as the y numbers get larger, the x values get closer and closer to 4. So that's a pretty good start in terms of how this is going to behave. But let me go with some negative values for y. So if y is negative 1, it kind of looks like x is 6. Can we convince ourselves of that? If y is negative 1, what do we get? We get x is 4 plus 2 to the negative y. The negative of negative y would be positive y in a sense. The negative of negative 1 is positive 1. So this is 4 plus 2, which equals 6. That 0.6 negative 1, isn't that what we said it was going to be? You come back here, and we see 6 negative 1. And let's do one more. So is there a nice answer? If y is negative 2, take a look. What do you predict the x will be? If y is negative 2, we can see that. And let's finish off with that. If y is negative 2, what is the x going to be? 4 plus 2 to the negative y. Negative y is positive 2. So that's 4 plus 4, so that's 8. So do we have the point 8, negative 2 on the graph? And you'll remember we certainly did. So we have 8, negative 2 there as well. Domain 4 to infinity, range all real numbers. So we are looking at those points. If you had created those points by hand, hopefully you could draw a reasonable graph showing the asymptote coming up here at x equals 4. And also showing that it's gradually trending down in that direction. Okay, so what are we going to do next? Maybe just get one more point for fun, negative 3. 4 plus 2 to the negative of negative 3, 4 plus 2 to the third, 4 plus 8 is 12. So we have 12, negative 3 there. So those are the points for y equals f of x. Now I want to graph y equals f of negative x. So we're going to go ahead and transpose those points. So what we just did on the previous table is x f of x. That's where we had 5, 0. We had 4.5, 1. We had 4.252. We had 6, negative 1. We had 8, negative 2, and we had 12, negative 3. So if I want to construct the graph of f inverse of x becomes y, y becomes x. That's our strategy. So 5, 0 becomes 0, 5. 4.51 becomes 1, 4.5. 4.252 becomes 2, 4.25. 6, negative 1 becomes negative 1, 6. 8, negative 2 becomes negative 2, 8. 12, negative 3 becomes negative 3, 12. So let's put those points on Desmos, and let's look to see what that looks like. So here we go. 0, 5, 1, 4.5. 2, 4.25. Negative 1, 6. Negative 2, 8. Negative 3, 12. So we can look at these graphs now. And the question is, does that look like the inverse to you? Could you draw that by hand? Where is the asymptote? Well, we saw for our original function, the asymptote was at x equals 4. So where's our asymptote going to be here? Well, x becomes y. If it was x equals 4 for this function, the asymptote for our new function must be y equals 4. X becomes y, y equals x. There we go. So we see our two asymptotes, so we can go ahead and draw in. So I want you to think about drawing this thing by hand. What would that look like? Coming this way, down, 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 and then asymptoting. Now there is a way for me to draw this on Desmos without actually solving it, which we're going to do here next or soon. Remember, my original function was f of x equals negative log base 2 of x minus 4. This is the original, or y equals negative log base 2 of x minus 4. If I want to graph an inverse, x becomes y, y becomes x. So y becomes x. So just rewrite it as x equals negative log base 2 of y minus 4. And that should go through the points that I've just constructed on Desmos. So let's see if that's the case. X equals negative log base 2, so shift underline, of y minus 4. And sure enough, it does. So those two green functions are both correct. F here, F inverse here. Notice they are symmetric with respect to the line y equals x, mirror images of each other. Now, what about the domain and range of the inverse? So this is my inverse function. We'll turn everything else off. Right? This is the inverse function. What's the domain? What's the range? Well, looking at this, domain looks like it's all real numbers. Range never goes below 4. Now, what can we say about that? So from the picture, it appears that the domain of f inverse appears to be all real numbers, whereas the range of f inverse never went below 4. So it went from 4 to infinity. So we get that from looking at the picture. However, we could have gotten that directly from before. Notice, here was our first page. X becomes y, y becomes x. So the domain of f has to be the same as the range of f inverse. right? Because x values in F are the y values in F inverse. So the range of F inverse has to equal the domain of F, which would be 4 to infinity. Similarly, the y values of F are the x values of F inverse. So the range of F has to be the domain of F inverse. Which is what? Which is all real numbers, which is minus infinity to infinity. And one more time, let's look at that graph just to convince you of that reality. Domain, all reals. Notice x get as low as you want it to get if you go out far enough. Range from 4 to infinity. Now, the last thing I want to do with this analysis is to determine what is F inverse. We've written it as an equation, x equals negative log base 2 of y minus 4, but what is that as a function of x? So again, what did we start with? We started with the function f of x equals negative log base 2 of x minus 4. Our goal is express f inverse of x as a function of x, right? We want to get f inverse as a function of x. Well, again, f is, as we've done before, minus log 2 of x minus 4. If we want to get an inverse, x becomes y becomes x. So now we have x equals negative log 2 of y minus 4. We want to solve for y. Multiply both sides by negative 1. Negative x equals log base 2 of y minus 4. I like the log on the left. Log base 2 of y minus 4 equals negative x. The base here is 2. The exponent is negative x. So 2 to the negative x equals y minus 4. Add 4 to both sides. 4 plus 2 to the negative x equals y. And that should be my f inverse of x. F inverse of x should be 4 plus 2 to the minus x. And let's check that on Desmos. So I will turn this off. Remember, that one is supposed to be the inverse. And we think the function is, I'll call it g of x here. I don't think I've used g before. G of x is 4 plus 2 to the negative x. And is that the same as what we had here? You can see indeed they are. So we have successfully determined what the inverse function is. F inverse of x is 4 plus 2 to the negative x. But again, the domain of f is the range of f inverse. The range of f is the domain of f inverse. Look at your graphs to help identify what those concepts mean.